And the floor goes to our next speaker, Ilya Motik, who represents Institute of Solar Terrestrial Physics, Siberian branch of the Russian Academy of Sciences, and who will talk to us about energy released during the decay phase of solar flares.
Okay, the sun today came out for a section to greet us, so do I. And as it said previously, my name is Motik Ilya, and today I'm going to talk about the energy release during the solar flares. Okay, let's first of all, I will tell you about what the solar flare actually is. So when you see on the sun images something like this, that something flashes on the image, it's most of the time the solar flare. Sometimes it's CMI or coronal mass ejection, but most of the time it's solar flare. And usually evolution of this solar flare is divided by two phases. The first phase is called impulsive phase, where the main energy release occurs. And the second one, and it's characterized by the rapid growth of the temperature. Also, the second phase is called a decay phase, when we see the decay of the eruptive, post-eruptive arcades and other things. And it's characterized by the gradual and slow cooling of the flare plasma. There are some models, analytical and numerical ones, that describe the evolution of the flare, and also during the decay phase especially. And all they assume that there is nothing else happens except two these processes which take place in the cooling. They are radiation losses and conductivity. Conductivity means that plasma simply cools by transferring the heat through the plasma. And radiation losses, I think it's quite understandable. But there are some problems, obviously. Flare cooling problems. The first one is how it showed in the research of Ryan et al. The observed cooling of the flare plasma takes a bit longer or much longer in comparison to the theoretically calculated ones. And also here I present the comparison of two time profiles of the modeled time profile of the line 304 angstrom and the observed one in orange. So, and you can clearly see that they are not quite similar. So, what's the problem? And our assumption in possible solution of this mystery, let's say that like that, it's to take into account additional heating sources. And why exactly additional heating sources? Well, usually when you observe some solar flare, there are some additional bursts on the decay phase, which we assume may somehow contribute to the heating of the plasma after the main flare onset. And there are some quite particularly interesting events, like for example this event, burst on tail, where the maximum of radio flux surpasses 1.2 times bigger than the maximum of the main flare, which is, as you can see, it's not quite common. But by looking at these profiles, obvious questions rise up. It's the first one: where they occur, where they happen. Are they connected at all to the previous flare? And what's the mechanism that generated them? To answer both of these questions, in our Institute of Solar Terrestrial Physics, we have this nice Siberian radioheliograph, a telescope in microwave range that can answer both of these questions. First, we see the location of the source on the sun's surface, and also we can obtain the information about not only when it happened, but the generation mechanism of this event. For example, just simply by looking at the spectral data, we can tell, I can tell, for example, was it accelerated generation mechanism or just a heating one? So, and by shape, just by looking at the shape of the spectrum, we can tell not the mechanism of generation, but also how it was accelerated, how much, and also derive some values like, for example, magnetic field or density of the plasma, and so on. One of the events that I analyzed, presented in my recent work, and we find out where the source is located. For example, we marked it as yellow lines, and it's clearly seen that it is somehow maybe connected to the solar flare, because they are located near to each other. And later on, with help of the other instruments in also microwave range, we reconstructed all the scenarios of this event and how it occurred. So if you are interested in that, I can answer you a bit later. And my current work is to study this event on July 17, 2023. There was a white flare that occurred on the sun's surface, and we can, with SRH images, we can clearly see the evolution of this microwave flare, and also how the post-eruptive arcade evolves, and we can also see where the density of the plasma is high and where is low, and also some sunspot sources like this, for example. And also, as I mentioned before, we can look at the shape of the spectrum of microwave range and clearly see this is typically gyrosynchrotron, which is particles spin around a magnetic line field, and peak frequency about 2 gigahertz gives us unusually weak magnetic field about 3 Gauss, which is in order to compare to the typical values, it's about 100 times bigger. So it's unusual, and we are trying to investigate it. And based on my showed studies, I came up to the conclusion that in order to create a proper numerical model, we need not only to take into account the 2 processes that previously mentioned, but also the additional energy sources like, for example, some bursts and etc. And spatially resolved observation in microwave range allows us not only to locate the sources but not only allows us to locate the sources, but also understand how they affect the heating of the plasma during the decay phase, which can be useful for defining the role of these processes and events during the decay phase. And that's all for today. Thank you for your attention, and I'm gladly listen to your questions.
Thank you so much. Questions, please?
Yes.
Question from foreign man of this.
Layman. It's called layman. Layman. From the outsider, maybe.
How often solar flares occurs?
Actually, it depends on the sun's cycle, because during the maximum of the sun cycle, we have sometimes like flares that occur like in minutes, like this one, like in this spot, in this spot, in this spot, and any others. And during the minimum of the sun cycle, we have maybe once in a month, once per month, for example. And but I would say average of this all is about maybe twice per month. I'm not sure about this because you know solar activity is not quite predictable as we want it to be because there are some cycles that do not have in them some flares or some like mandatory minimum where there were no sunspots. And like for example, we have seen like few maybe days ago, there are 3, I guess, flares of the X class, five flares of the X class, and this is like, I don't know, exciting news for us because these flares occur so rarely that we just want to study them.
Okay, and the second question, for example, let's imagine that happened many flares, as you said, here, 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 and here. You should study all these flares, or the biggest
Well,
which ones are most attractive?
most attractive, I would say, these where we can, those which we can observe with our SRH telescope. Because, as you know, maybe that the Earth rotates and not all the instruments can observe the sun like 24/7. And so the favorable ones are, first, they are observable by SRH, and the second, most of them, and the second, they have like visible events during the decay phase. They are interesting for me, especially. But for the other but for the other scientists, they may be different. For example, some particularly tricky flares. I don't know. So it depends on the.
Yeah.
Can we return to the slide number 2?
Oh, yes.
And here we can see 3 pictures. What's the difference between them?
They are just different lines of the UV spectrum. This one, for example, is what. This one, for example, is 171. This is 304, and this one, if I remember this correctly, is 97 angstrom.
And what specific facts do they show? Those pictures?
Here we can see how the iron iron 5 is ionized. Here we can see the line of hydrogen, H alpha, and here we can see, I don't remember correctly, but some elements as well.
Another elements, I see.
Yeah.
And how are those events, those solar flares, connected with our life on the Earth?
Well,
Is there any kind of connection?
well,
Something happens there on the sun, and what happens here?
there are clear connection because all the storms, magnetic storms that occur on the around the Earth, they are caused by these solar flares. Particularly those which are located in the west side of the sun. Because when the Earth travels around the sun, it just like catches up this cloud of the particles, and this what causes magnetic storms on Earth. Yes.
More questions?
If it have an effect on our health or the environment, how we can manage
To predict them. Right? Is it right?
How can we manage the
Wow,
effects on
how
our
do we-
health and environment?
I'm not especially qualified to talk about this. It's more about medical, but as far as I know, maybe there are some connections, but honestly, I don't think that there are such more connections that it's just gravitational, because most of the magnetic fields we don't feel them. Maybe birds feel them, but we don't. And most of our electronics and the main goal of the predicting these, for example, flares and magnetic storms, are for the facilities, because they are they are more sensitive to the magnetic fields, and they can be damaged by them.
Okay. So
For example,
that
satellites and.
Okay, interesting. Thank you. Anything else? Any more questions?
I have not like a question, but like some additions to the Ilya's answers, because about how the sun connected to our health, and so it's kind of more to my field of work.
Okay.
I just wanted to add that actually not the flares making, I don't know, moving plasma from the sun to the earth, and already this solar wind interact with the magnetosphere of earth, and that makes some polar shining and some affection on the people.
Disturbances.
Yes.
I have quite a counter-argument to your words. We can have a scientific discussion about that.
Well, okay,
We'll
I
discuss.
think we're just running out of time, so thank you so much for embracing such an amazing topic. Let's applaud to Ilya. Thank you indeed. Of course, we can always continue. Yeah, all right, our next speaker to